Recently, news came in about another major construction project in China. This time, China's drilling a hole so deep that Mount Everest could fit inside it. It's located in the middle of the Taklamakan Desert in the Tarim Basin, a plain surrounded by mountain ranges. The well was named Shenditake-1, and it's expected to reach its planned depth of 36,400 feet after the work is completed. It's worth mentioning that this is the first research well in China designed to exceed a depth of 32,800 feet. Moreover, Shenditake-1 could become the second deepest vertical shaft in the world and the deepest in Asia. This super deep shaft is really supposed to exceed the height of Mount Everest, which is 29,032 feet above sea level. Honestly, unless you've seen Everest, it's tough to realize just how huge it is. So let's use something more familiar to understand the scale of this monumental project. Imagine the Eiffel Tower. It's 984 feet tall. Well, you could fit 37 Eiffel Towers, one on top of the other, inside the Chinese borehole. Here's another comparison. The shaft created will be deeper than the Mariana Trench, which, by the way, is the deepest spot in the ocean. The shaft is expected to reach the Cretaceous system in the Earth's crust, a series of stratified rocks that are 145 million years old. Why is this important? Just imagine, Chinese scientists get access to the rock that covered the planet during the early Cretaceous period. That was the time when there was no ice at the North or South Pole. They were covered in forests. Dinosaurs like Diplodocus and Stegosaurus roamed the Earth, while small mammals scurried beneath their feet and birds were just starting to evolve to fly. In fact, any information about such ancient Earth history is extremely valuable. Discoveries that Chinese scientists might make thanks to this drilling could turn out to be priceless. So, right, first coffee, and we'll continue. And right now, an unobtrusive reminder to hit the like button if you usually do that. Drilling of the Shenditake-1 well began on May 30th, 2023, and in less than a year it passed through 13 continental strata. Over 1,000 drill pipes were driven into the ground and more than 20 drill bits were used. This is what the drill bit looks like. It's a cutting tool, and it's basically what makes the drilling process happen. And since the bit is the part that encounters all the rock's toughness, it wears out the fastest. So even by the number of pipes, you can tell this is a massive project. And that means it has its own set of problems. In a way, even unique ones. For example, drilling a well of this depth requires moving about 2,000 tons of equipment and tools. To just start drilling the ground, a 20-story steel tower was set up, and then a drill bit, drill pipes, and casing pipes were used, which together add up to such a huge weight. And don't think that it's enough to set up all the equipment, tools, and other stuff just once, and then keep an eye on it to make sure nothing breaks. It's much more complicated. As you go deeper, the drilling rig is constantly upgraded, changed, and improved, because the drilling conditions also change from layer to layer, and you need to adjust to them. Actually, this isn't the first time such deep drilling has been done in human history. People have done similar things before. Currently, the record belongs to the now-closed Kola Super Deep Borehole in northwest Russia. The Soviet scientific drilling project lasted 20 years and reached a depth of 40,230 feet. Another record is held by the BD-04A oil well at the Al Shaheen field in Qatar. It's 40,322 feet long, but that's just the length, not just a vertical drilling depth. At the moment, the longest well is the one drilled for oil extraction on the Sakhalin Shelf, Z44 Chavo, a record 9.3 miles. But again, that's length. This is still not depth. But let's get back to the Kola Super Deep Borehole. In this case, it's more fitting to compare the new Chinese project with it, and not only in terms of depth, Chinese engineers are going to drill it in an incredibly short time. So the Kola Super Deep Borehole started drilling on May 24th, 1970. And reached a depth of 31,440 feet on June 6, 1979. Meanwhile, China plans to finish its project in 457 days. Of course, it's important to note that more than 50 years have passed since the Kola project began. The technologies have advanced significantly since then. Even during the drilling of the Kola Super Deep Borehole, some discoveries were made. For example, scientists unexpectedly found water and hydrogen at depths where they didn't expect to find them at all. Another interesting find was the discovery of microscopic fossilized plankton at a depth of nearly 20,000 feet below the surface. They actually found 14 types of fossilized microorganisms, not to mention deposits of gold, copper, and nickel. Meanwhile, despite the intense pace of work, the easy drilling stage for China has come to an end. real challenges lie ahead. After reaching a depth of 32,800 feet this spring, drilling will face more serious problems. Just dealing with temperatures exceeding 392 degrees Fahrenheit and reservoir pressures over 130 megapascals is daunting. And with each additional foot, the difficulty will only increase. A scientist from the Chinese Academy of Engineering compared the construction challenges of the drilling project to driving a big truck on two thin steel cables. In other words, while it's theoretically possible, it requires a tremendous amount of effort to make it work. For example, selecting the right cables. In our case, this equipment is designed for underground temperatures up to 392 degrees Fahrenheit and the corresponding atmospheric pressure. But it's not just about being under the ground. Besides the extreme conditions deep below the surface, the harsh environment of the Tarim Basin, where the hottest and driest desert in China is located, makes the work even tougher. But I'll get back to the chosen drilling site a bit later. For now, a few more words about what's down below. The thing is, after reaching the 32,800-foot mark, attempts to break through the unknown begin, because very few people have managed to drill that deep. Because of this, there are no standards for drilling, no information, parameters, basically anything to learn from. No one else's mistakes, only your own. Because of this, the deeper the drill goes, the slower the work goes, and the more drill bits need to be changed. For example, drilling 3,300 feet took only 4 days. Drilling from 29,500 feet to 32,800 feet took 70 days, and the average speed was 47 feet per day. Also, rock analysis is conducted before drilling each foot to check if a change in equipment is necessary. The deeper the drilling, the more intricate and time-consuming the analysis becomes. It's important to avoid rushing this step to prevent equipment malfunctions that could stop drilling altogether. I wonder if this could explain why there are so few ultra-deep wells. To understand better, let's examine some specific cases. Let's get back to the Kola Super Deep borehole. Despite the significant depth reached, the drilling encountered unexpectedly high temperatures and high rock density. All this led to the project's halt in 1992, and in 2005 the well was sealed. This happened before they managed to reach the goal. It was planned to dig down to 49,000 feet, but it became just too difficult. So I have a question. Is it possible to dig an even deeper well? Or maybe is it impossible to break the Kola Super Deep's record at all? Well, if you check out the history of drilling worldwide, you'll see that we've only gotten to 0.19% of the way to the center of the Earth in 300 years. Doesn't exactly look like a win. But here it's important to understand what we're actually dealing with. The outermost layer of the Earth, the surface we stand on, is the continental crust, and it's about 25 miles thick, and that's a very thin layer. The next layer, the mantle, is already 1,800 miles thick. After it comes the outer core of the Earth, which extends about 1,400 miles, and beyond that is the inner core. It's hotter, denser, basically an iron ball with a radius of around 750 miles. The Kola Super Deep borehole penetrates only about a third of the continental crust. It seemed like there was still so much more to drill. However, 50 years ago, practice showed that digging a deep hole to the center of the Earth is much more difficult than researchers originally thought. At least because at that depth, everything is quite different from what we're used to. When the temperature hits 356 degrees Fahrenheit, the Earth's rocks begin to act in unusual and even surprising ways. For example, if the rock has greater porosity and permeability, it behaves like plastic rather than a solid material at high temperatures, making drilling nearly impossible. This is one of the difficulties encountered in the Kola Super Deep borehole. Besides, not much equipment can actually withstand such temperatures and keep working. Even using cooling systems is very difficult. Keep in mind, the well is over 6 miles long, so delivering cold water or other cooling liquids will have to be done over a huge distance. Also, drilling to greater depths will require even more advanced equipment. While drilling the Kola borehole, a drill bit would last only 4 hours. So every 4 hours, they had to pull the drill up, swap the bit, and then send it back down. All at this depth of over 6 miles. But the drill bit has to be changed because this is how it looks before starting work and after some time. Temperature also affects the consistency of the rock the drill has to go through. The hotter it gets, the more liquid the environment around the drill becomes, making it harder to keep the channel open. It's kind of like trying to keep a pit in the center of a pot of hot soup. You can do it while the spoon is moving, but as soon as you pull it out, the hole disappears. And yet attempts to drill even deeper into the Earth all the way to the mantle were made by different countries, but they just didn't work out. For example, in the spring of 1961, a group of American geologists began drilling a hole in the ocean floor off the Pacific coast of Baja California. Little did they know that soon all their efforts would be forgotten, because in May of that same year, the space race had begun. People were far more interested in space, so the geologists who dreamed of catching a glimpse of the Earth's internal processes were left with nothing due to budget cuts. Well, almost. They got some leftovers. Some attempts to reach the mantle failed due to technical problems. Others became victims of all sorts of setbacks, including picking the wrong drilling locations. On top of that, the technology needed to make these journeys to the center of the Earth had to be invented from scratch. It was expensive. The American project spent, in today's money, about $40 million for every few feet of drilling. Plus, there were temperature problems that no one was prepared for. The Americans even claimed that the place where they were drilling was hotter than the place where the Soviet geologists and engineers were working. But actually, in the case of the Kola Super Deep Borehole, it wasn't just about the challenges they faced, and it wasn't even about the accidents. The interest in the project was simply lost, and with the collapse of the Soviet Union, the funding stopped. Without it, continuing the work was simply impossible. One can only wonder how deep the Kola borehole would have gone if the money had kept flowing. Honestly, it makes me a bit sad that no one's willing to spend millions of dollars purely for science. There always have to be some extra reasons to fund research. And China does have those reasons. First of all, of course, there are scientific reasons. Such deep drilling will allow scientists to learn more about how the Earth was formed because the Earth's crust is kind of like tree rings, allowing us to study what happened to that tree. Only here, the scale is much bigger and the time periods are longer. After all, we're talking about the formation of the world. Scientists are already calling the Chinese project a telescope into the depths of the Earth, because there you can find evidence almost at the level of stars. Here are samples collected from deep within the Earth using a Chinese drilling project. They might not make much sense, but they're really intriguing. A deeper understanding of our planet's contents will allow us to better predict and forecast events like earthquakes and volcanic eruptions. This information is crucial and vital for our safety. There are also economic reasons for drilling and various serious commercial incentives. For example, it can provide access to potentially lucrative energy reserves buried deep underground. That's why this region was chosen for the construction of the ultra-deep mine. It's a major area for mineral extraction, and engineers hope to discover gas reserves there. Both companies involved in drilling the well in China are large, state-owned oil conglomerates. So in addition to studying Earth's history, the main goal is to determine whether there are still oil and gas deposits at great depths, because China is in dire need of energy. Recently, Xi Jinping declared energy independence as a key priority for national security. To ensure everything goes well, new energy sources are clearly needed. Although the site for drilling is highly challenging, this is exactly where the Chinese government can obtain what they're seeking. But there's another project that seems even more impressive than the Chinese and Soviet ones. An international team of researchers plans to drill through the Earth's crust down to the mantle. They plan to do it with the help of the Japanese drilling vessel Chikyu. If scientists manage to reach the mantle, which makes up 83% of the Earth's volume, they'll gain invaluable insights into planetary formation and plate tectonics. Researchers are optimistic. Despite previous failures, drilling technology has advanced significantly, and our understanding of the oceanic crust has improved. Although American efforts fell short, the progress in deep water drilling by the oil industry over the past 50 years has made a huge difference. There are now advanced drilling bits, tools, and instruments that are more resistant to high temperatures and pressures. However, the Mohole to the Mantle project needs $1 billion to drill through the bottom of the Pacific Ocean to reach the mantle. That's a hefty sum. The plan is to find a thin section of the crust at the bottom. This way they'll have to drill less and can dig deeper. It might actually work. Piece of mantle. Recently, scientists managed to drill a well under the Atlantic Ocean using the marine drilling vessel JOIDES Resolution. The team obtained a 4,160-foot-long core, which represents an almost continuous sample of mantle rock. This will allow for a better understanding of the planet's deep geology and might offer a new perspective on the origin of life. The well was drilled in a volcanically active region of the Mid-Atlantic Ridge located along the bottom of the Atlantic Ocean. But if it's so hard to reach the mantle, why did someone suddenly manage to do it in almost the blink of an eye? The secret's in the location. Actually, here it wasn't necessary to dig deeply into the rock. Although the mantle is usually located much deeper than the crust, it's exposed due to a fault in the Mid-Atlantic Ridge. So the mantle was just, well, you could say, carefully scraped off. This happened at the beginning of August, so there are no research results yet, but I'll keep an eye on the news. A hole to produce energy. In June 2009, a drill that had drilled thousands of feet into volcanic rock in northeastern Iceland suddenly got stuck. Well, it happens. When they tried to remove it, researchers discovered solidified magma. The work came to a halt. After many years, they've resumed drilling and now want to use the hole in the ground to produce geothermal energy. How does it work? In general, geothermal energy is produced by extracting heated water from a deep well. The higher the temperature, the more efficient the system. A deep well can generate several times more energy than what's currently produced in Iceland with the same method. What if you jump there? What if you find yourself on the edge of an ultra-deep well and you want to drop something down? Scientists have already figured out what'll happen if you drop a person down there. Of course, assuming the hole is wide enough for a person to fit through. Naturally, such a fall would be fatal. The first likely killer is the temperature, the second is the pressure, and there's also a big risk of hitting walls because the person will bring rotational acceleration due to the planet's spin, so just try not to fall into super deep holes. Shooting in the well. Since we're talking about things dropped somewhere deep, it's worth mentioning that deep wells are made not only in the ground, but also in ice. Obviously for scientific reasons. Recently, scientists revealed what ice thrown into a deep 450-foot ice well might sound like. It sounds as if a bunch of little stormtroopers from Star Wars were sitting in that well and randomly shooting in all directions. You owe me a like. See you later.